Okay, so after Greg's introduction, I feel like I ought to say something about the definition of architecture, which is something I'm going to have to do on the fly. But it's a fair point. What does that actually mean? I've met people with titles like chief architect that probably could not have defined it. I'm going to try and take a very narrow view of this here. What I'm going to try and cover is what do you need to do at a coarse-grained level, at a high level in the construction of an application, of an AJAX application and GWT in particular for obvious reasons, so that you don't get into trouble. Where trouble is defined, there are a lot of kinds of trouble, flavors of trouble. You don't get into usability holes. I'm going to talk about history support. You'll see why, but history is actually surprisingly relevant to architecture, and it's something that you do actually need to consider from the beginning. So it is actually really relevant to this topic. I'm going to talk about the way that you model your data, not the data itself so much as the way that you maintain that model. How does that model live on the client? How does it live on the server? How do you communicate those two? And how do you communicate data to your UI elements, your views and so forth, and then back to the data model, back to the server? Again, this is another place where you can get into a lot of trouble if your design does not take into account the realities of a web application, in particular an AJAX style application. I'm going to talk a little bit about the implications this has for your server. Not so much the deployment topics that others have already discussed, but things like how can you take advantage of additional statelessness that you can achieve in your server by keeping state on the client. And I'm going to spend a little bit of time talking about authentication. It's a little bit of an odd man out on this list, but the topic has come up a lot of times in the past, so I'd like to discuss that a little bit as well. So I say by old school AJAX, I largely mean what people are actually doing right now. I'd like to redefine that as old school in light of better applications that I suspect you will all be building soon, with the exception of those of you who already have. Most applications, if you go and tear apart your average AJAX application, where you end up is you see this page, you see some bit of it that is dynamic. That is, it does something without the rest of the page refreshing. That's kind of come to be the definition of AJAX. We used to call this DHTML, but it has a fancy new name now, so now we call it AJAX. Those applications don't really have an architecture. They have no, in my experience, the ones that I've seen, they don't seem to have a data model for the most part. They just say, for example, I'm going to make an XML HTTP request, fetch some stuff on the server, and dump it into some part of the page. When you press this button, I'm going to do that again. Maybe I'll refresh automatically. That is very effective. It's certainly a lot better than what you get when you do full page refreshes. But it's really not, it doesn't answer any of the really hard questions that come up when you want to go a little bit further with that. So, for example, if I have a paged data table buried in an otherwise static HTML page, very often you'll see those, they'll bolt these into existing applications and they'll just refresh the data whenever they need to. Press next, 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 it refreshes, grabs a new page of data from the server. It's certainly faster than the full page refresh, but it just keeps fetching it. If they cache anything at all, it can be a lot faster, but very often they don't really have any kind of coherent caching model. There's no scheme for deciding when a page is valid or invalid. And they just tend to get inconsistent and not worry about it, assuming that you will eventually refresh, or they will just refresh for you. That gets you a certain distance, but once you want to go a little further than that, you've got to answer a whole host of much trickier questions. So what I'm going to propose, and this is fairly straightforward, but what I'm going to propose is a data model where you have a client web browser. You've got views, various UI elements that you create and so forth, widgets and so forth. And you've got a model that lives on the client. The model really, it's not really diagrammed well here, but the model really lives on the client and the server. I mean, somewhere fundamentally, logically, you've got a data model. So, I'll use email as an example. It's a pretty easy app to think about, and everybody uses it. The data model looks something like, I've got a user, so I've got a user and an account. I've got a list of, I'll use Gmail since I use that all the time. I've got a list of threads or conversations, each of which contains a list of messages. So, it's not a horribly complex data model, but even so, it becomes, when you're trying to build something like Gmail, you can end up in an inconsistent state very easily if you're not careful about how you synchronize that model with the server. In particular, given there's a lot of updates coming from the client. I compose messages and send them to the server. I would like to have quick updates on the client, but I would also like to make sure that the client still remains consistent with what the server's view of that data is. For anybody who was here for the applications panel last night, if you saw the Lombardi blueprint application, who here saw that? Anyone? Everyone, cool, almost everyone. You didn't even see the coolest part of that demo. Those guys did a great job, and they could only have done this with a really, really consistent model and consistent architecture for keeping track of how that's stored on the clients and the servers, and on multiple clients. So what you didn't see, as I recall, was, somebody correct me if I'm wrong, I don't recall seeing this, 2 clients operating on the same model. You saw the boxes fly out when you added new elements to that list and that tree, and it was nicely animated and everything, and the updates were consistent across multiple views, which are obviously backed by the same model. But if 2 clients are editing the same model, they're seeing each other's changes in real time as well. Those are the kinds of things you can only do with a consistent architecture. You'll get yourself into a serious mess if you try to do that without a coherent model of your own, a mental model, and also an instantiation of that in your code. So another thing that sort of implies is, as soon as you have an explicit model, you have classes that represent your data model, you start to think of your UI objects in terms of views. Anyone familiar with Smalltalk or MFC, model view controller, or MFC document view architecture? Just the simple concept. We're not going to talk in great detail about what constitutes a controller, because people apparently will argue about that all day. But, or Swing for that matter, same kind of architecture, borrowed from Smalltalk. The important thing is that you have a model and you have a view, and that is a clear and coherent distinction. So, you can have multiple views on the same model. That's one of the things, like the Lombardi application does a great job of demonstrating how well that works out if you do that. And a change that takes place in one view as a result of one view, is obviously automatically applied to the others. This gets a little more complicated when you move to multiple clients. Again, the Lombardi guys did a great job solving this problem, but with a coherent model, that it tends to fall out fairly naturally. Now, this is a little bit of a loaded term, but I'm going to use the term dependency injection to describe this. This is a pattern that I have found out works very well in applications that I've worked on. I've heard this described as dependency injection. I'm not referring to any kind of a complex framework involving reflection and XML and all that. Just the idea that you have view objects, you have data objects, and when you instantiate a view object, if its model is invariant, just pass it into the constructor, treat it as an invariant. If it's not, you can get setters and getters. That adds a little more statefulness to your views. But that pattern is something that I strongly encourage. Make sure that the views don't know exactly about their model. Make sure they're working through some kind of an abstract interface. That makes it a lot easier to test your code, because you can make mock objects a lot more easily. And it makes it a lot easier to refactor your code, because you don't have all these static dependencies among the various bits and pieces of your app. Now, in sort of a traditional model view controller app, you can ask simple questions of your model. Your view can say, okay, give me this piece of data, and expect to get a response as a return value, or something similar, something synchronous. Well, this will work. There we are. That isn't that simple in the web environment. You're in a distributed environment, your calls to the server are asynchronous. That really can complicate things pretty drastically. So when I write if anyone used the quit RPC mechanism, you see code like this all the time. When I ask for a piece of data, I can only expect that it will come back at some point in the future. And really there's two very important things that derive from this. One is it complicates your code because everything looks sort of like a continuation. It's all callback based. Two is because of that, you have to ask yourself, what am I going to do with my UI while I'm waiting for that data to come back? It would be really nice to write synchronous calls. For reasons that you may well be aware of, that's pretty much impossible in a browser environment. For one, they don't work. But even if they did, you would have to lock up your UI for every call that you made to the server. And those things can take, depending on what you're doing, they can take multiple seconds. In theory, they can take any amount of time and never succeed. But I mean, even as a matter of course, like normal circumstances, they can take a few seconds. It's not unusual. At bare minimum, they're going to take 50 milliseconds or so to pull out a number. That has a lot of implications for how you build this model. So what you end up doing, and one other thing just to point out, it's pretty obvious, but you also got to think about failure. One of the nice things about the RPC interface is that it explicitly makes you think about failure. You at the very least, have to leave an empty method that says on failure and know that you're doing that whenever you write one of these calls. It's really good to think about how you're going to handle those up front because it does affect the state of your application. The state space of your application becomes much more complex when you can fail. And especially when your UI is in, say, a waiting state or something, depending on how you decide to handle the interim state between when you ask for a piece of data and when you get it back, failure can make that even more complex. Something that's really important to think about that up front. What also happens as a result of that is you have to have that same sort of callback model in the interface to your data model. So this is called client-side code, right? I'm going to ask an account object for the list of, or for the top 10 email conversations in my inbox. If I ask for that data, even though I'm asking the client-side model, it still has to be, I still have to receive the results of that as a callback, either a callback or an event, but either way it's asynchronous. So that interface, it's the interface to the server implies, the asynchronous interface to the server implies an asynchronous interface to your data model. That also creates a bit of complexity that you're going to have to think about. But it's important, like this is a hole I sort of ran into when I was writing a sample app. Wasn't thinking about it very carefully, and I wrote a synchronous interface to the data layer. Well, there's no way to make that work. You're going to have to write it asynchronous, write everything in terms of events. The good news is once you do that, you can abstract out concepts like whether the data is currently cached. So if I ask for a thread list, give me the top 10 threads in the inbox, there's no reason that the data layer can't either A, turn around and make a call to the server, get that data back, stick it in its cache, and then fire the event, or say it's already there and I think it's valid, therefore I'm just going to immediately fire the event back. It may even happen effectively synchronously, but from the user standpoint, that is the view standpoint, that happens, it's invisible. The other thing about having an explicit model in the middle is that it gives you a place to do that caching and to have a coherent caching policy. So, caching policy is one of those things that's very application specific, and a lot of the time it's, you just kind of have to think, well, either I can know that this is possibly invalid, or I'm just going to give it some sort of timeout or what have you. If it's a thread list is more than a minute old, I'm going to consider it invalid and refetch. Kind of depends on the application, what you can and can't know. But it gives that stuff a place to live so that all the views can be abstracted from it. And even though the code becomes fairly hairy, most of the people working on the app don't have to worry about it. So I'd like to take a minute actually. So I'm about to switch gears a little bit. Does that seem reasonably clear? And I know this is not entirely, it's a fairly abstract conversation. I tried to put more actual code examples in here and so forth, but it's just really hard to show in 24-point fonts on these slides. But can I get a quick, can I at least do a quick straw poll? Is there anyone that is thoroughly confused by this concept or just thinks that it's not coming out clearly at all? Okay, I have a couple of hands. So let me think about that for a minute. I didn't really create any good samples of that code. The best way to look at it, I think, is to look at it in terms of this interface. Any view asking for data from the model is going to have an interface that looks like this. Rip off the on failure part, assume that that's handled at a more sort of application global level. I mean, it doesn't have to be, but it typically would be. But just basically remember that I guess the short form is you're going to have to write callbacks everywhere to make this work coherently. Scott?
There's another part to it we saw, which is once you get used to the idea that updates are going to be flying to the server continuously and coming back, at not just continuous, but unknown times.
Right.
You start to think about your application differently. If nothing else, you decide, well, it's not an unusual event for my application to be told there's new data to display. It's a common event, and it's a very common state for some part of the in-flight update.
Right.
So make sure that it makes sense to the user even while it's grabbing data.
So for the benefit, I'm going to restate that for the benefit of the recording, assuming that didn't make it onto the recording. It's a really good point. Scott is one of my cohorts at Google who's been working on a fairly large GWT application. Correct me if I misstate this, you start to think about your application once you realize you have all these asynchronous events, asynchronous updates, asynchronous fetches. You start to think about your application in terms of there being a bunch of requests in flight at any given time. These things come in out of order. Like things never come in the order in which you request them, very seldom. The user can have several outstanding events or several outstanding requests and or updates flying sort of in flight at any given point in time. And you have to think about how your application is going to react and how you're going to display the results of these actions as they come in at various times. And that time, I think it's safe to say, is measured in seconds. I mean, it's very coarse-grained events, which makes a big difference because you have to think about what state the UI is going to be in if this update completes before this request completes, vice versa on a lot of different outstanding events or a lot of different outstanding requests. And also, it introduces error states in the middle as well. So you can have 3 requests, 2 requests and an update, and one request fails, the update succeeds, and the other request succeeds. The best general advice I can give on dealing with that is that I don't know if, Scott, this is your experience, but what I've seen typically is that you kind of have to actually just draw out what all the possible states are to a certain extent so that you can think through this through. The other thing that happens is that actually ties back into UI design, because you've got to think that your UI designers have to be aware, especially if they're used to dealing with standard HTML applications, where there's an extremely coarse-grained state. There's page. That's easy to think about, but it's not the reality when you're dealing with a lot of asynchronous updates. Hopefully that will give you some idea. I wish I could say more than just give you an idea of what you're up against, but at least knowing that allows you to think about it up front. These things do tend to be pretty application-specific problems. Of course, you can always cheat and just say, every time you do any update, I'm going to lock up the entire UI with a dialog box that says you can't click anything while I'm doing this. And that's, for certain applications, that's not entirely unreasonable. It depends on how much time you have to get all those states right. What you don't want to do is not think about it until, you don't want to delay thinking about it until you think you're almost done. and move into a production environment. Dietrich?
Isn't that putting a timeout on these things an important thing?
So yes, the question is, should we put a timeout on these things? So the reality is a timeout is put on them for you, but that is of course a browser-specific thing, and you will get a failure. You will get an exception if they fail. It'll either, the question is when, and sometimes that can be quite a while. It depends on the browser. There is an interface whose name I've forgotten, and I think it's in 1.5 actually, that allows you to get a little more control over the request, the outgoing request in an RPC. So if you need to tweak those kinds of things, tweak timeout period and so forth, I believe that is now possible. It was not in 1.4 to my knowledge. But that is something you have to think about as well, because it may simply fail. We've all seen HTTP requests hang for no good reason, or no good reason that I've ever been able to discern. And that's something you're definitely going to have to think about as well. Giving the user a chance to resend one, that's important, because you've got to say, in the old days, we had this, in the bad old days, let's say, we had pages all over the place on big sites, even financial transactions, who would say, please do not hit refresh or you will trade twice. That problem doesn't go away for free in an ajax application or in a GWT application, but at least it gives you enough leverage to actually think about what you're going to do if the user says, it's been 5 minutes, or it's been 30 seconds, or it's been 10 seconds, whatever, somewhere where I've been comfortable. And I want to hit go again, and I want to be guaranteed that it won't commit twice, or charge twice, or trade twice, or whatever. So hopefully that gives some useful information, sort of a broad overview of that problem. So I would like to switch gears a little bit now and talk about sort of coarse-grained structure, application structure. The way that I put the application as a whole together, and the way that I deal with an application when I want to break it up into multiple pieces. I'm going to start with the history mechanism. This might sound kind of overly specific. That is, history, it's just a feature, right? It's one little library with like 3 methods in an event. But thinking history through carefully makes a very big difference in the structure of your application. So essentially you've got 2 choices. To put it simply, you either do history or you don't. If you don't, what your application is going to do, because keep in mind it's a web browser and you cannot make the back button disappear, you can only make it not do anything. And actually you don't really even have that much control. So if a user goes into your application, you have no history support, and it's a single page application, and they hit the back button, the application is going to close. That is not always the behavior people expect. And I would go so far as to say that's not the behavior they ever expect. You do get the opportunity, you can get a window closing listener and you can stop it from being unloaded if the user agrees to say, okay, I want to stay on this page. We've probably all seen that a few times. Gmail does this, I believe, in a few places. The downside to that is that, you do need that as a guard in some instances, but the downside to that is you get this dialog box that you don't have very much control over. You have control over a little string in the middle, and you don't have control over the names of the buttons or anything. So it's basically okay or cancel, which semantically is not usually very clear, ever really. And it's a pretty bad user experience, I think, in practice. So if you can support the back button, that's really a good thing. If you want to support it, though, this is the question you have to answer yourself, and this is where it really ties into architecture. You have to answer the question, what is a location? Because that's what history manages, right? It manages a stack of locations. In order to have them, you must define them. On the traditional web, that comes for free, although you have very little control over it. You get back, forward, it moves you to the previous and next URLs that you were at. Sometimes that does what you want it to, sometimes it doesn't. So when you're doing this explicitly, when you're modeling history explicitly, you get the opportunity, and to a certain extent it's a burden, but you can also view it as an opportunity. You get the opportunity to define the concept of a location so that your application can have a consistent history model. What I would like to do is show, I can now show this because Gmail recently fixed, I can find it, the back button completely. It sort of worked before, but, oh, that's not the one I wanted. That was my hippocampus, by the way, which is actually pretty cool. I was just looking at it. Oh, wrong one. So you get to see the contents of my inbox. Hopefully there'll be nothing embarrassing in here. So it's becoming a norm in Ajax apps because it's basically the only way that works we're abusing the hash part of the URL. That's the sort of interior linking part of the URL to denote internal application state. That works actually pretty well. It has a couple of really good properties. One, when you change it, it doesn't refresh your browser window. Two, it is considered the same URL for the purposes of caching and so forth. So you're not screwing with your cache by modifying it. And three, there was a third. What was the third? Oh, it makes your application state linkable. So this is the model that users are at least told to expect. I know in the traditional web it doesn't always work the way they expect it to, but at least it mostly works. You know, I expect to be able to send URLs to my friend, and they should link to the thing that I was looking at when I sent it. In Ajax apps, that doesn't typically work. Now, if I open up Spam from The Economist, this has changed to this path. Now, this structure tends to be application specific, right? The definition of what your locations are is application specific, and so most likely should be the structure of your history tokens. We call them history tokens in our history library. Gmail's model is the sort of the path to how I got where I am. It's usually, in my limited experience with it, it's usually either label. Inboxes are considered labels, I think. Label or inbox or what have you, / like a message ID or thread ID. Fairly coarse-grained, but it's about what users expect. The beauty of this, of course, is if I hit back, if I can find my cursor, I go where I was. Even better, though, if I copy this, it takes me to the exact same spot. That is the behavior that users expect. And if you give that to them, that is extremely useful. It's a very coherent model that I think will serve, tends to serve applications very well. Now, I've lost my window. Oh, here we are. So our history mechanism looks like this. Basically, you have a history object. There's only, it's application global, so the methods are static. You have a history listener, which has an onHistory changed event, not surprising, and it passes you in the token that was associated with the hash mark, so hash whatever, that value. Then it's really up to you to parse it and to serialize it. We talked originally about building that in so that it was automatic. The serialization came for free. The problem is URLs only can store roughly 1K of data. So any generic model, really, any generic serialization tends to put more stuff in it than you need. So it's much better just to write that serialization and parsing code by hand. You end up doing it once. It's usually pretty straightforward. In Gmail's case, you can imagine it probably looks like a little bit of string manipulation code, and that's it. And when you want to define a new application state, you simply say history.newItem and serialize your current state. So once the only hard part is defining the model. Actually, working with the library and getting it to go is pretty straightforward. And now it works on every major browser with the exception of Safari 2, which is physically impossible to support. Anyone who thinks that it is supportable, I'll be glad to prove to you why it's not. I only say that because I spent many, many sleepless nights trying to get it to work. But thankfully, Safari 2 is being aggressively upgraded to Safari 3, which works like a champ. It even works on IE. That part kind of was surprising to me. I mentioned this already, bookmarks for free. The nice thing about that is, in addition, one other useful thing is I can grab, there's all these things built in for working with bookmarks, right? So I can grab the little icon next to the URL bar, at least on Safari, and drag that to my desktop. That creates a link. I can double click it. I can email it to people. If you play nice with the history system, there's some great things like that you get for free. You can even create hyperlinks internally in your application that themselves can be clicked on and dragged to the desktop, or right-click, open a new tab, or open a new window. Again, having a consistent model makes that all work for free. But not having a model at all makes it always do the same thing, which is just reload your application. Not really the best property. So I also want to say a little bit about breaking up large applications. The first thing I want to say, this is a caveat we keep saying over and over again, because it is, a lot of people have the tendency to try and pre-optimize this case. That is, I think my application code is going to get very, very large. Therefore, I want to break it up in advance into multiple pieces, into multiple separate applications. There are legitimate use cases for that, but it is preferable, I would argue strongly preferable, to avoid it until you absolutely have no choice, because multiple applications are never going to work together as well as a bunch of code compiled into a single application. As evidence, supporting evidence for that point, I noticed that, was the light supposed to go out, by the way? I'm less blinded now, but I'm not sure if we're having video problems as a result. Anyway, I noticed that we have Luc Clay here with us, who is you're the CTO, correct, of Contact Office, which if anyone has not seen this application, it is a marvelous example of a large, complex GWT application. Luke probably knows more about application architecture than I do, because he's built a bigger app than I ever have. And this is a perfect example. It has email, discussion threads, contact lists, complex contact lists for that matter, user editing and so forth and so on, a calendar with drag and drop, all this stuff. There's a huge amount of stuff in there. And it is, how much is that compiled? 700 to 900K?
900K.
Okay, 900K. Those could have been built as separate applications, but when compiled together, they stayed perfectly reasonable, and it starts up really fast. I'm really impressed with it. So all that just to make the point that don't break your application up until you absolutely have to. If you have to, and this is the important corollary to that statement, the compiler will do a good job separating multiple entry points into the bits of code that you actually need for those. So it is a decision you can defer until much later. You might have to think, there will be some things you will have to think about, which I'm going to talk about now, but you won't have to think about them unless you actually do have to break it up. So you can save a lot of work by not breaking it up until you have to, and I strongly hope that you won't. There's a fair probability, if you're concerned about code size, there's a fair probability that by the time you get done with your application, we will have optimized the compiler even more and it won't be a problem anymore. That's my hope. But in the event that that is not the case, there's really two sort of broad approaches. And what I'm addressing here is the approach, is that in general, the idea of taking an existing application, making two entry points, and compiling them into two separate pages, or two separate modules to be loaded into separate pages. You can either work those modules into the same page and simply load from one to the other. So for example, if I were writing an application, mail application with a settings page, the settings page is usually pretty clearly and naturally separable from the main page. So I can either, when I click the settings button, I can either simply navigate to the settings application, maybe passing a little bit of extra state into the URL to know, which user we're working with and so forth, which works pretty well. Although that's another case where you'll want to have implemented history, because when you back up into the original app, you want to be back exactly where you were. That is that makes a big difference. Otherwise, you end up reloading the app when you back out of the settings page and losing all of your application state, which is really no good. The other option is, as the bottom two bits of code indicate, you can put it in a frame and host it in your page. And it's a little ugly conceptually, but it works perfectly well. You create an iframe, put it in your page somewhere, and load some separable piece of your application, like a settings page, into it. Or you can also do a pop-up. Obviously, you have issues with pop-up blockers and so forth, but sometimes that's actually the right approach as well. So essentially, one of those two options, to put it in crude terms. I found that most applications, in my experience, tend to have these broad chunks, that it's these coarse-grained chunks into which it is naturally separable. So I keep talking about settings page as an example, but that goes for a lot of things. You can have, if you have a large chunk of code in a tool for, that's a good example. I'll use AdWords as an example. Anyone who's ever used AdWords, you have all these separable bits of tools like keyword suggestion tools and things like that. They don't really need to wind too deeply into the main application flow. There's not really a big deal to put them in an iframe or a pop-up window. In fact, they often do. If anyone has a good example of an application that grows kind of without bound and doesn't have those naturally separable components, please let me know. I'm still looking for a good example. I'm sure one exists. I just haven't found it yet. So again, when you think you've hit that brick wall in size, look for those places where you can naturally separate your application. Okay, a couple of brief things, and then I'll actually open the floor for questions. This, I think, most people get fairly naturally, but if you don't, it's worth recognizing. As we've mentioned this, I think, in various talks before, when you move all of your session state into the client, the stuff we used to call variables, this has become session state in the web world, which is stuff that you grab and you shove into a database, and every time somebody makes a request, you grab it back out of the database, or you put it in some sort of shared cache somewhere. It's expensive, and it makes your servers stateful, or it places a massive amount of load on your database, usually one or the other. When you move all that state into the client, it is usually possible, at least in my experience, to have essentially stateless servers. Recognize that fact. Think of it as like REST. I mean, that's the way a lot of people think of this. A stateless server gives you free scalability. As soon as your server becomes stateless, you can add 1,000 servers to support load. I can't help you with your database backend, but it's certainly better than shoving lots of session state into it. So definitely remember to take advantage of that if at all possible, because scalability is your friend. We at Google can attest to that. Sir?
Joel, I gotta call you out on that. You got massive security problems if you're gonna start storing things like what's in your shopping cart, what role I am, QA versus a general manager versus admin. There are certain things you can't put to the client because you can't trust the client.
Okay, sorry, can you say that into the microphone? Let's open the floor for questions, so we've got 5 minutes, and you can say that again.
So you can have massive security problems.
Nope, there we go.
You can have massive security problems when you do that. Like, I have a session state variable that I normally store, depending on what you're running on the server, view state, session store, whatever, that is, defining my role in the application. QA versus, general user versus admin. Shopping cart size. I can put things in my shopping cart that I'm not supposed to. I can put negative product IDs.
Yep.
You really want to be careful about what you put on the client because you can't trust the client.
Yes, listen to this man, he is correct.
I mean, I totally 100% agree with you on scalability, but there are certain things that you simply can't put to the client.
Right, so if I can say really briefly, I just want to say it depends on what you're trying to do, but yes, you're absolutely right. You do have to think about that. Trust but verify. Well, don't trust at all, just verify. But what I do want to say about that briefly though is there are a lot of bits of state for which that does not matter. If you're dealing with shopping carts, verification is very important, as anyone who wrote an application that allowed people to enter negative prices can attest to. I believe that's actually happened in practice. But the issue, if you're talking about scalability, you have to be careful, but there are so many things that get shoved into session state, usually, that don't actually need to be there. They would have been variables if you were writing normal programs. And if you take that load out of the equation, put it in, you can call it session state, put it wherever you need to, but it gives you a lot more leeway for doing things like sorting shopping carts and so forth. Most of your requests are for little things like, I don't know, give me the list of counties in Arkansas or something. All these requests that you're making to the server, normally you're very often going back and grabbing a session object just to get some small piece of data that could have been stored on the client. That's the kind of thing that I'm most concerned about. But yes, and anyone listening to this, please take this man's words to heart, because you don't want to be in the situation where you're trusting stuff that matters from the client.
Well, the stuff you're going to trust to put on the client is stuff once you've authenticated in. So once you've authenticated in and established a secure session, you know who you're dealing with, or else they're not getting the actual application by definition.
Right.
So at that point, you can pass off what you want to the local system, not client, because it's a smart local system.
Right. That is often true, although the shopping cart example is a counterexample to that, where...
Well, even with a shopping cart, you still got to log in and password, say who's actually using this shopping cart.
So this is, let's take this offline, because there are a lot of really important issues to be discussed here. Mainly, I just wanted to point out that you can indeed get a lot of load off the server this way.
I've got 2 minutes. We'll
2-minute warning.
One here and one here.
I'll try to be brief.
One of the things, we've built a fairly large application. One of the things that's really helped us in getting out of the session heavy mindset is just to look at the server session, as a cache, as a database cache.
Right.
And so you encode as much of what you need on the client, and then if you need it on the server, just use it as a cache. If it's in the session, grab it. If it's not, go grab it from the database, and that's helped us quite a bit.
Yeah, no, that's a good point. I believe there's one
We
more
have
back
one
there.
more in the back here.
Just think about architecture. You went through it on history. Where did you go and what do you want to do? What about user preferences and things like that? Last slider position or splitter position?
Yeah, that's
baking that in up front. Any best practices for GWT?
right. That's actually that sort of thing is a tough call, because you don't typically want to bake that into your actual history state for the reasons that normally you'll run out of room. Although depending on your application, sometimes that is possible. This is something I didn't really cover. There are tricks for actually caching a little extra data outside of that is sort of outside of the history state, but stored so that if you go out of the app and back into it, let's say, that bits of sort of transient data can be restored. That's something I'd be glad to talk about that. I'm not going to have time right now, but there are a few sort of wacky strategies you can use to get around that problem. Or for general user preferences, though, it's not unreasonable to store those on the server and regenerate them, or re-download them every time you start. If you have a login process, it's usually an opportunity to save UI state, and then you just model your UI as part of your data model, essentially. Those UI preferences and so forth.